module. So it is an option, depending on what platform, to actually further provide protection for your private keys by setting them or saving them within a specialized hardware security module on the box, a FIPS certified hardware module. So the type of key, I'm going to do a key signing key. I'm going to kind of keep the rest of the defaults, but you'll also notice down here, obviously being able to change the TTL, the rollover period, and the expiration period. So one of the things that they've done nicely under the covers is the ability for us to handle automated key rollover within DNSSEC. So with DNSSEC, it's best practice that you're going to roll over these keys. You're not going to use the same keys forever. So we give you a very, very easy option to actually expire keys out, or what they call key rollover. So after a certain amount of time, you're going to roll over to do DNSSEC keys for the key signing keys as well as your zone signing keys. So we kind of automate that process for you as far as being able to specify a rollover period as well as an expiration period, and that's what those are kind of leading to.
And everything, it seems like, is just fill in the blank. Pretty easy to set up for an administrator.
It's very, very easy. This is a very complex process if you actually try to just do it within a normal DNS bind server, where you've got to drop down to the command line and you're running scripts, and we've really put a very, very nice GUI wrapper around the whole solution. There's my key signing key. The next thing I'll want to do is go up and create my zone signing key.
And if I remember correctly, these were sort of based on the NIST standards, right? We kind of took a little bit from that to ensure that we're matching up to what NIST is sort of recommending when it comes to DNSSEC.
That's absolutely correct. Yeah, it was a really big push from our government customers for us to implement the DNSSEC functionality, and we actually found some guys over at NIST that were writing the standards and writing the recommendations for how the government should implement DNSSEC. So we actually went under NDA with those guys over to NIST, ensuring that the solution we were developing was going to meet all those government standards. So it was quite nice to work with them and get their feedback as we put the system, or as we put the code together.
Wow. What better way than go to the source?
Exactly. So now I've got my two keys, my key signing key. I've got my zone signing key. I can then go under my zone list. And the other thing that's nice about this is that I'm going to be able to sign the entire zone. So any WAD IPs I would have under the xyz.com zone, this would take care of them all in one step. So I could have 20 different WAD IPs from www to FTP to secure.xyz.com, and through this 3 steps or 4 steps, I would basically provide DNSSEC for any of those WAD IPs I have in this parent domain. So there's my zone signing key, and there's my key signing key, and the state's obviously enabled. And away we go.
Now, with global server load balancing, it seems like a lot of this stuff, with the signing and you want to ensure it's coming from an authoritative server, but global server load balancing, it potentially, the IP address could be changing, the location could be changing, because GTM is going to be making those intelligent decisions as to where best to kind of deliver the answers out. So does that matter that, maybe locations are changing, data centers are changing, IP addresses might be changing?
It really, in most DNSSEC implementations, it would absolutely change. So if you weren't using a global traffic manager to intelligently do this DNS resolution, if you wanted to fail over a data center and you had a DNSSEC mandate, you would have to manually go in and change that DNS. But another part of the process now is you would have to re-sign that zone because your resource records have changed. So you're adding more complexity to that manual failover, that manual DNS intervention that needs to occur when you're not using a global server load balancing. So because we're doing all this on the fly, we're actually answering or signing, DNSSEC signing the answers as they leave the system. So we can be handing out different answers to different clients based on locality, based on application availability, and it's just the way that we've made the solution work or coded the solution. We are just answering these responses on the fly. So if we're failing over data centers, if we're doing any of the goodness that Global Traffic Manager gives us, we don't have to come in and change any part of the DNSSEC configuration.
And the customer could also potentially have, if I'm correct, some DNS servers or some domains, I should say, on the back that need to be signed, and then maybe there are some others that aren't that critical and might not need to be signed. And still, this single implementation of the Global Traffic Manager will still answer all and any cases that are getting requested of it, whether they need to be signed or not signed at all.
Exactly. We can totally work fine in a mixed environment where you have DNSSEC mandates for some zones and no DNSSEC mandates for other zones. So it's just a matter of how you put the configuration together. Some of the other things that will play quite nicely with the Global Traffic Manager, and this is kind of just its core infrastructure. When the GTM sync their configurations and share state, we've always done that through an encrypted SSL tunnel. So that also comes into play very, very nicely when you're dealing with this DNSSEC and having to share these keys across your entire DNS infrastructure through all the DNS servers that are authoritative for your particular zone or domain. So because we've already used SSL as a communication path between all of our GTMs, when you configure DNSSEC on one of your GTMs in a sync group, that automatically gets propagated down to the DNSSEC keys, public keys, and private keys to all the other GTMs within your what we call a sync group. So basically configure it once on your master GTM, and then all that configuration along with those keys propagates through an SSL encrypted tunnel to all the other devices within your sync group.
Right on. So you created the two keys and you created the zone list. Is there anything else?
I'm actually done. The only thing that, just to reiterate, I did already have my Global Traffic Manager configuration in place. We already did have a WAD IP for like www.xyz.com. So those are just basically the 4 additional steps that are needed to actually DNSSEC secure any of those WAD IPs in my xyz.com zone.
Right, but an administrator would have to do that in the initial config anyway. Right.
Exactly. Just basically 4 additional steps is all that's required.
Wow. That's really cool. So we're kind of getting toward the end. Is there anything else you'd like to share, Michael, or show us?
I don't think so. I mean, I think for our exercise today, we kind of covered the points we wanted to. I mean, obviously, for more information, for evaluations and things like that, just you could just contact your sales team and kind of go from there. But yeah, I mean, it's a really, really, really nice solution, and it's a really, really easy way to become DNSSEC compliant, all GUI based. On top of the DNSSEC compliant, you get all the goodness of global server load balancing, application health checking, data center proximity, data center link saturation, things like that. So it's a new level of that intelligent global server load balancing F5 has always been providing.
Cool. So there you have it, ladies and gentlemen. BIG-IP Global Traffic Manager and setting up your DNSSEC. In 5 easy steps, actually less than 5, huh, Michael?
Less than 5.
Less than 5, all right. Well, thanks for joining us today. That was actually quite interesting.
Thanks for having me.
And right on. And to our viewers, thanks for watching. Again, this is In 5 Easy Steps. It's the In 5 with F5 series. And so for Michael, this is Peter Silva for F5 Networks. Thanks a lot.